Now you're all set these questions in a random order, so I'll just go through them in a random order as well. I'll talk through the solutions as I go. One of the important things, these are past paper questions, they were quite challenging. But if you look at the marks, quite often in the written parts, they can tell you a lot. So this is worth 4 marks. A standard calculation in physics is worth 3 marks. So that tells you there's going to be something different about that. The two main possibilities why it might be worth 4 marks could be that there's 2 steps to it to get the answer, or it could be that there's a mark for looking up something in the data sheet. So in this question, just like anything else, we look carefully at what information we've got. Now there's a number, just watch, but it's not written as a number, so make sure you're getting round all your information. So we have that the number of waves is 4 in a time of 20 seconds, and that we've got the wavelength is 12 meters. That's the information we're given, and we're asked the speed. Now there's more than one way of doing this problem. Some of you went down different routes. I'll go down one route, but you could do it more than one way, and I'll show you that in the marking scheme as well. I'll show you that in a wee second. So first of all, what I would look at is, I've been asked the speed. What formulas do I have for speed? Well, I've got v equals d over t, I've got a equals v minus u over t, I've got v equals f lambda. So basically the two main ones that would stand out there would be v equals d over t or v equals f lambda. And when I look at this, I think, well, I've got the lambda, can I get the f? Well, I've got an n and a t, so I have another formula for f, which is linked to n and t. And that's why then this is worth a 4 marker. So that's explaining why there's 2 steps. So the first thing I'm going to do is work out f before I can use that to work out lambda. Okay, and that's our formula, n over t, and that gives me f. And now I can do my v equals f lambda calculation. And don't forget things like units at the end. And that's the answer. Okay, so in terms of standard marking, well, we'll look at the marking scheme in a wee second, but generally remember for a standard 3 marker, you're 1 for formula, 1 for substitution, and 1 for answer. Here is the SQA marking scheme for it, and you can see their standard solution is just the route that I've gone down. You get 1 mark for the calculation of f, and then standard 3 marker formula, substitution, and answer. But it does show you here other methods doing it. So if you did go down the v equals d over t route, you'd be saying to yourself, well, it was 4 waves, each of wavelength 12 meters, so I could do that as the distance is 48 meters. Or you could say, well, what do I know about one wave? I know that its length is 12 meters, one wavelength. And I know that because there's 20 waves in 4 seconds, each of them must be 5 seconds long. All of them give you the same answer. And you can see a few other notes down the bottom here that will appear in the SQA marking scheme. So it's quite a lot there, but it is good to start to get used to looking at SQA marking schemes. We'll do that a lot more throughout next year. So in the original for this question, you were actually asked to draw the diagram yourself, showing what would happen. So I had to adapt the question a wee bit, and what I did was to give you 2 and ask you to select basically the correct diagram and justify it, and then a more straightforward factual one just based on what's the dashed line called. So the correct one here is A. And the reason, and I think part of it, some of you actually struggled quite a bit with this one, and I think it's almost because you're so used to these diagrams where the rays coming in from that side, and you're looking at, say, a glass block and the air there, and then your normal comes along that way. Excuse me, I'm sketching these very quickly. But basically with this one, the gap between the boundary between the materials is horizontal instead of vertical like here. So if I actually start, that's the normal, do that with part 2. And so there's your ray, right? The light's made it to the fish, and then it's got to make it to your eye in order for you to see it. So basically the two possibilities are either it bends towards the normal in diagram B, or it bends away from the normal in diagram A. And you should know that when light leaves a more dense medium, like glass or water, it bends away from the normal, so that's why A is correct. It's going from a smaller angle to a bigger angle. I think somebody said that capital R is bigger than capital I. I did give you the mark, but actually in the SQA exam you wouldn't get the mark without explaining what capital R and capital I are. You'd actually have to define them, so you'd have to say something like the angle of incidence. The angle of refraction is greater than the angle of incidence. So diagram A is correct because the ray bends away from the normal. In leaving a more optically dense medium. And then 2, as we've discussed, D is in fact the normal. The normal is always at right angles to the surface. If the surface was like that, triangular prism for instance, right, wherever the ray hits, then you would draw a line at right angles to the surface. Now there is no SQA marking scheme for this because I adapted the question. These questions are all from 2014, 2015 past paper if you want to look at. Okay, so this question's got quite a lot of diagram information that you've got to work carefully with, making sure you're getting everything you can out of the question. So first of all, we do have a number here, we have a speed of the ultrasound, and we've got this idea of the ultrasounds, right, transmitted into the steel, reflected, that's an important idea, and detected by the ultrasound receiver. Okay, so both the transmitter and the receiver are the same object here, so the waves are coming out, bouncing off, and going back. And we're doing this at position X and at position Y. And then it tells us these two times are plotted on the graph here. So we have got a graph of the amplitude of the reflected signal and the time, so how long it took for those reflected signals to get back. And then we've got the actual questions. So state the time taken to pulse being transmitted and received at position X. Now if we go back to here and look, can you see that the thickness there is bigger at X? Which means that that pulse is going to take longer because both of these pulses are travelling at the same speed. They're both in the same material. So that one's got a shorter distance. It's going to complete it in less time. And the other kind of clue that this is the correct one for X is the fact that it's a wee bit weaker when it's returned. The amplitude of the reflected signal is smaller, simply because it's travelled a wee bit further. So more of it's kind of getting absorbed in the material. So putting all that together, that's how we know that which one's X. So the answer to part 1, wrong pen, sorry. The answer to part 1 is 15, but then we've got to read carefully the units. Now I did forgive this a wee bit. Some of you wrote a U and an S because it's hard to get the micro symbol. But it's 15 microseconds. Now you can just write that as your answer, that's acceptable. You can convert it, you're going to have to anyway when we get to part 2 at some point. But that is the correct answer for part 1, and that's why we know it's correct. And then in part 2 we're asked about the thickness of the steel. Now we don't have a formula for thickness of steel, but what we do have are formulas for distance. So basically that's a wee bit about, this is a good one, about why it's so important to think about what is this question actually asking me. It's asking me a distance. Okay, it's very easy to list everything you know, but it's asking me a distance. And similar to the previous one, which is why I said this is quite challenging, because in the final paper you'll not get as many, you wouldn't get 4 marks, 2 4 markers out of 17 marks. Right, that proportion isn't right, so I haven't picked my questions that well here. So the 4 marks, remember, tells us either we're going to look up some information, well we don't need to because we're given that speed here, or else it's going to be more than one step to our answer. And then we've got our time that we just worked out. But this is where the key idea about the reflected pulses is very important. Remember, this is an echo problem then, because the waves are going out and coming back. So the time for the thickness is actually half of that time. Now you can go ahead and calculate a distance travelled and then use that to get the total distance travelled and then half that to get the thickness. You can do it either way around. You'll see in the marking scheme in a wee second. And before we put this into an actual calculation, then we are going to have to use the fact that you should know that micro is 10 to the minus 6 seconds. Now we can do our standard D equals VT calculation. Remember, this is a formula that people mix up a lot. Always check it in the formula sheets when you're doing your assessments at home. Check against your notes. And we plug all that into a calculator to get the answer, which is 0.039 metres. Does that seem sensible? It's 3.9 centimetres, so yes, you're not likely to have a thickness of a piece of steel of 39 kilometres or something like that. Okay, so it's always worthwhile looking at your final answer and thinking, is that sensible in the context of the question? So if we have a look at the marking scheme for that. Now here we go, it shows you the 2 ways of doing this problem and shows you how the marking is split up. So part 1, fairly straightforward, 15 microseconds. And then for part 2, I did it using method 2, down here. So I divided the time by 2, used that to get distance. But you can do it by doing the working out the total distance travelled, and then half it to get the thickness. And basically it's a standard 3 marker with the 4th mark being for halving either the distance or the time. But also remember, if you got A part 1 wrong, we've got this bit here consistent with A part 1. So if you got that wrong, if you chose 5 microseconds or various other things, then you should be able to get full marks for part 2 by carrying that forward, or even 3 out of 4 marks if you forget to half and so on. So following on from that question, we've got the idea of technician replaces a steel sample with brass. It's the same thickness as the steel did at position X. Technician transmits pulses of ultrasound into the brass at position P. I've got quite a lot of reading to do again here, but similar basically setup, except it's brass instead of steel. The time between the ultrasound pulse being transmitted and received at position P is greater, so I would say that's a kind of key idea, than the time recorded at position X in the steel sample. State whether the speed of ultrasound in brass is less than, equal to, or greater than the speed of ultrasound in steel, and you must justify your answer. These are quite a common type of question, and you'll see the way that they're marked. So basically you get a mark for getting it right, and you get a mark for justifying. If you make no attempt to justify, you don't get the mark for getting it right. If you justify but you don't quite get it right, then you can still get that first mark. But if you justify with wrong physics, then once again you lose that first mark. So it's kind of checking your understanding. It's not just, you can't just kind of guess these. And basically what do we know? Well, we know the time is greater and we're being asked about the speed. So really what you want to think about is, well, what's the link between speed and time? What's the formula? Speed equals distance over time. And you can either, in your answer, incidentally, you can write your answer first and then do your justification, or do it the other way around. But to me it makes much more sense to actually do the justification first, and then that leads you to the right answer. If you're doing a descriptive answer, if you write V equals D over T, you've then got to explain what all those symbols mean. So it's actually easier to do these word equations. So speed is distance over time. We're told that the time is less. Oh, sorry. Well, we're told that time is greater. Read the question carefully. and we're told that the distance is the same, and this is a point of justification that a lot of people missed out. So if you did that calculation dividing the same distance by a bigger time, you would get a smaller answer. But you don't get the second mark for simply saying the speed is smaller because the time is greater. You need to at least show for the idea of the same distance. Okay, so you'll see that in the marking scheme as well. There's a marking sound, and like I said, you get first mark can only be awarded if a justification is attempted. Right, correct answer, basically correct effect, they're calling it justification, correct 2, correct effect, justification, and correct 1. Right, effect correct, but no justification attempted. 0. And if you get the effect wrong, even if your justification is right, you don't get that mark as well. And basically what you'll see, although you don't actually need to say the word same, it's not just enough to say it takes a greater time. Right. If you just said to travel that distance, then it implies, or even you're saying here, if you just said to travel distance, then that would be acceptable. Okay, it's just, but I think the same makes it a bit clearer. So remember, for multiple choice, still do full working for the calculation ones. Right? Two main advice for multiple choice was, if it's a calculation, ignore the 5 answers, do it as a full calculation as you would normally, and then once you've done that answer, check to see what's available. And the big thing here for a lot of you, you went for A instead of C, if we label these A to E. And the reason you've missed out that key idea, it's 8 milliseconds, which is 8 times 10 to the minus 3 seconds. And therefore the frequency is 1 over the period, is 1 over 8 times 10 to the minus 3, so 125 hertz. That's the correct answer there. And this one, what you've got to be careful about is your definitions of amplitude and wavelength. So you've got information in this question up and down, and information across. And the question is asking you about wavelength, so it is across that matters. And if we look across, can you see there are 1, 2, 3 waves in that 18 millimeter distance. So 3 wavelengths equals 18 millimeters. The wavelength is 18 divided by 3 is 6 millimeters. So D, if we listed them that way. And for these types of multiple choice questions, they are reasonably common. You probably get about 2 in your final exam next year. Really just take each statement one bit at a time and think, do I agree or do I disagree with that? So in the air, microwaves travel faster than radio waves. I would say no, that's wrong. Okay. Part of the reason to answer that is we actually need part 3. They are all electromagnetic waves. They're all part of the electromagnetic spectrum, and by definition they all travel at the same speed. In the air, microwaves have a longer wavelength than radio waves. Well, remember our spectrum, you're expected to know, right? Your good xylophones usually vibrate in musical rhythm. I forgot what R was there for a wee second. Okay, so looking at this in order, right, microwaves and radio waves, you see both appear at the long wavelength end, but can you see that microwaves are before radio waves? So this is the longest wavelength. So 2 is not correct either. Radio waves have a longer wavelength than microwaves, not the other way around. And microwaves and radio waves are both members of the electromagnetic spectrum. That is true. So the answer is B, 3 only.